All right, so let's go ahead and talk about conditional statements. So conditional statements fall under what we call control flow constructs. Basically, there's two main things that we often use to control how our code operates based off of certain requirements. And we generally call this control flow. And it's simply the order in which we code and have our statements evaluated. The two main ways that this happens is through conditional statements. And this is where we specify things to happen only if a condition or a set of conditions are met. And then we have repeating operations. So this is any action to be computed for a multiple number of times. And the way to think about this is typically the if-else type of statements that are common across many languages. Those are conditional statements. If something is true, go ahead and execute this code, else execute other code. For repeating operations, typically when you think about for loops, something where we have a common operation that we want to iterate over and perform multiple times, that is a common repeating operation. So for this lesson, we're going to really focus on the conditional statements part of it. In later lessons, we'll talk more about how can we do iteration within R. All right, so the most basic form of a conditional statement is just a simple if statement. And we use if to execute code when a single condition holds. And the way to think about this is if some test expression is true, execute whatever code statement we have within the parentheses. If not, then we do nothing. So what does this look like? Well, let's take an example here. Say we have a random number here. If we go ahead and run this, we can see our random number is actually x. So 0.507. All right, so if we wanted just to do a very simple condition, and let's say if x is greater than 0.5, execute this code, right? So recall, and we've seen these conditional statements before when working with dplyr, right? When we do x greater than 0.5, right? This is just a conditional statement saying, is that true or is it false? If I were to say x greater than 0.6, since x equals 0.507, we'd get false. So all that if is looking for is a true value. If something is true, then go ahead and run this code. So we see our output has basically what this code produces, just this statement here. And if x, or in this case, if the statement does not meet the condition, for example, x is not greater than 0.7, then nothing happens, right? Our code just moves on to the next code chunk and it doesn't produce any output. All right, so knowing that, here it says talk with your neighbors, but just pretend you have neighbors around you as you're watching this. Question is, what do you expect to happen with this example? We have a vector here of both positive and negative values. And we say if x is less than 0, go ahead and just perform this print statement. What do you think is going to happen? Actually, what does happen is an error, right? And it's because our conditional statement has a length of greater than 1, okay? So recall, if I were to let me take this vector, and I just want to test, is this vector less than 0, I actually get a true or false statement back for each element in that vector, right? This is a problem because this if statement, it is not vectorized. So it is simply looking for a single true or false value. In this case, we have 4 false and true values. And so if does not know what to do. Okay, so there's multiple ways we can get around this, but just realize that if in itself is not a vectorized operation. So there's a few different ways we can work with this. Let's say we wanted to look for if a single condition holds among multiple inputs. Okay, so in this case we have our x, and let's just say we want to assess if that condition holds across at least one or more of those elements, right? So we can use this any statement. And any is just going to look at our conditional statement that we saw here, and it's going to return true if there's any true values across that vector, which in this case there is, right? We had this one true value. There's one instance where our condition holds. So now any will return just a single true. There's also an all statement. And all is just saying will or does this condition hold across all the elements? Well, in this case, it doesn't because we actually have 3 falses. So all in this instance will return a false. So what we can actually do, if within our conditional statement, we only care about does this condition hold across just at least one element, or does it hold across all of them, we can use any and all within this if statement. And then now, since we get one single true or false returned, if will execute properly. Now, there's many different use cases of an if statement or a single if statement, but most commonly I see them used in functions and then also in loops. For example, within functions, lots of times you see if statements, just a single if statement, to assess the inputs, the arguments. Is the user passing arguments that are appropriate for that function? If not, they can throw an error. In loops, lots of times you basically are going to check some condition, and if it holds, then it's either going to skip an iteration or it's going to break out. And we'll see examples of these actually in the next 2 lessons. So don't get too hung up in the details here. Just realize that a single if statement is often used in these 2 cases. All right, now that's just a single if statement. What if we want to assess or execute code based off of whether that condition is true or false, right? So we need to build onto this if statement. We can build onto it with an else. And we can see how this code is written here, or this is kind of pseudocode, where we have if some test expression is true, execute this code. But if it's not, we want to execute this code in this else statement, right? So if something is true, execute something else, execute other code. All right, so what does this look like? Well, let's go back to our earlier example where we have x, right? So now we say if x is greater than 0.7, execute this code. Else, if it is not, we're going to execute this code. All right, so now we are going to get basically some type of code is executed regardless of if the condition is true or false. All right, so take a quick second and pause the video if you need to. Take a look at these 2 chunks of code, which look very similar. And can you tell me which one is correct and which one is not? And if it's not, why? Hopefully what you notice is that in this second code chunk over here, we put the else statement on its own line. And that's actually incorrect, and that causes an error to be thrown, right? So the proper way to write an if else is after the parenthesis or the brackets that encloses the if statement, you take one space and then you execute an else statement. So the else statement has to be on the same line as the closing bracket of the if statement. Okay, now often we have multiple conditions or we have multiple operations where code is executed based off of differing conditions, right? So what that means is we don't want to just simply do code if something is true or if it's false. A lot of times we have to check multiple conditions. And we can do this by basically daisy chaining multiple if-else statements, right? So in this code, what we're doing is we're actually going to check for 3 different conditions. First condition is if x is less than 3, we want to execute this code. If that does not hold, then what we're going to do, we're going to check if x is equal to 3 and x is less than 8. And then that's going to print out or execute this code if that's true. And if that's not true, then we end with a final else statement, and then this will be executed. Right? So this is a way where we can look at maybe multiple different conditions that we want to assess and have more than just one or two operations executed based off of the conditions that hold. All right, so what I want you to do is go ahead and see if you can fill in the blanks in this code chunk here. And what we're trying to do is, if the month, right, this month variable here, has a value of 1 to 9, then the file name printed out should be data/month hyphen and then 0 and then the value of x. Okay. Now, if month has value of 10 to 12, what we want to do is have the name printed out as data/month, and then it's either going to be 10, 11, or 12. Right. So the main difference here is our month file names, if it's a single digit, has a 0 in front. So we need to create that proper name. But if it's 10 to 12, then it has no 0 padding in the front. Right. So we're trying to figure out which pattern we want to use to create our file name based off of the month input. Now the last thing is, if month is an invalid month number, so if it's not 1 through 12, then the final else statement needs to print out invalid month. And once you've completed that code, go ahead and test it on when the month equals 6, 10, and 13. All right, so I hope you got through that. Let's go ahead and take a look. Now here, you're going to see this exact same if, else statement before each line, okay? So I'm going to execute this with month equals 6, month equals 10, and month equals 13. But all of these lines of code are the same. All right, so let's take a look at what it looks like. So if month is in 1 through 9, all right, so let's go ahead, and if I just do month equals 6, and I just say if month is in 1 through 9, so that happens to be true. So if that's true, then we're going to execute this code right away, which we do, and we can see that this is the result of our code. Now, when month equals 10, all right, what we see is if we were to rerun this month in 1 through 9, well, that's false, right? Because 10 is not within that 1 through 9. But when we get to this second if statement here, is month in 10 through 12? It is. So we get a true there. And so that means this if statement gets triggered because it's true, that condition is true, and we execute this code here, which results in this name. Now when month is 13, then this does not hold, so that's false. This does not hold, so this is false, which then jumps down to the final else statement, which just prints out invalid month. All right, so what we've been talking about is a non-vectorized approach, right? So with the normal if and if-else statements, it's not vectorized, right? So we either check for a single variable value, or we can assess if all the conditions hold across all the elements, right? We're kind of limited to that. But a vectorized approach means we have basically a vector of values, and we want to iterate over each element, assess if the condition holds, and then have some code executed for each element, right? So that is a vectorized approach to doing this conditional statements. So how can we do that? Well, we've got a couple different options. If we just have a single if-else type of approach, where it's a binary response, if the condition holds, execute this. If it does not hold, execute this. We can use either a built-in if-else statement, right? So we see here, let's create this x. So x, we can see we have basically 5 different random numbers, and then we added this NA, right? So we want to iterate over each of these random numbers and assess if the values are greater than 5 or not. If they're greater than 5, I want to execute greater than. If they are less than 5, then we're going to execute less than. Okay, and we can see when we execute this, now we get less than because the first element is less than 0.5. Second element is less than 0.5, so we get less than. Third element is greater than 0.5, so we get greater than, and so on. And you can see that once we get to this NA, well, we can't really assess that. So all that returns is NA, right? Now, dplyr also has a built-in function called if_else, okay? And this is very similar. The main difference is that we have some flexibility in how we treat the missing values, right? So we can do this right here where it executes the exact same thing that this if-else statement did. However, when it comes to a missing value, we want to execute this code. So now we can see instead of getting this NA as an output, as we did up here, we actually get this something else, which is what we want to execute when we run into a missing value. Okay, so pretty much if-else and dplyr's if_else are going to operate very similarly with just minor differences such as this. Now, lots of times we want to do multiple conditions, right? So we want to do like 3 or more conditions. Well, the easiest way to do that is to use a basically dplyr case when function, okay? So we can look at dplyr case when, and we can, so basically the description is this function allows you to vectorize multiple if-else statements, okay? So if you're familiar with SQL and writing SQL code, SQL has a case when statement, which is very similar to what we're doing here. All right, so let's look at this this vector we have here of 10 random numbers between the values of 0.2, or excuse me, between values of 0 and 1. Then we add a 3, we add an NA and an F, right? So we have this vector that we see here, right? For the most part, everything's between 0 and 1. Then we have this value of 3 thrown in there, and then an NA and INF. All right? So how does dplyr work? Well, or excuse me, how does a case when function within dplyr work? Well, what we do is we pass in our conditions to assess, right? This is very similar to what we've been seeing in the other if and if-else statements. But we have a little bit of a different syntax, and it's this tilde and then the code to execute. So in this case when, just realize all that we're doing is we are returning a character string. But I mean, you could change this to where, you know, if x is less than 0.3, then execute, and you could have like, you know, some math going on. X times 10 plus 14 or something like that, right? In this case, we're simply returning character strings. So the way to read this, and this is in case when operates in a sequential order, and this is very important. So what's happening is I look to see for each element is x less than 0.3. If so, return low. If not, then we're going to go to the next condition. And this is if x is less than 0.7, right? So now the way to think about this is if we get to this line, it means that x is equal to or greater than 0.3 because this code was not executed, or this condition did not hold. So that would naturally mean that x here is equal to or greater than 0.3 and less than 0.7, okay? And if that's the case, execute this code. If that doesn't hold, then assess is x at least less than or equal to 1, and if so, execute this. If it's missing, right, we can assess missing, have this code executed, and then at the end, if none of these prior conditions hold, basically what it does is we just say true, right? And this is like similar to the final else statement in an if else, okay? So if none of these conditions hold, then execute this code. Okay, so what I'd like you to do is take this code that we already worked on, and this was the solution that we did in the last your turn, but I want you to turn this into a vectorized approach, right? So now we have month is not a single value. Month is actually a vector of values 1 through 13. I want you to convert this code into a vectorized approach. And there's a couple different ways you could do this, but turn this into a vectorized approach, and then I want you to go ahead and test the results on this vector of values from 1 to 13. All right, so I'm guessing the approach that you took, or at least this would be the approach that I would take, is using the case when statement. All right, so now what I'm going to do is, first of all, I want to assess if the month value, right, if each element in my month vector is within values 1 to 9. If so, then we execute this first line, right? So we have tilde, and then basically copy and paste that line here. If the element does not meet that condition, if it's not 1 to 9, then now let's check and see, is month in 10 to 12? If so, then we execute this code. So you could literally just copy this over and do tilde, and then that code. And if it doesn't meet that condition, which now would mean if the first condition doesn't hold, so the value of month is not 1 through 9. Second condition holds, so the value of month is not 10 to 12, which means the month is not a value of 1 through 12 at all. Then we execute this final code, which means you're passing an invalid month parameter, right? And the result is going to be, for each of our values a month, the path, the file path to that file, all right? And we see the last one for month when it was equal to 13, which is the last element in our month vector. We see we get invalid month. All right, so most often we are using a lot of these if-else or dplyers, if underscore else, in the case when within dplyr. And we often use this within a mutate function when we are creating a new variable, right? So for example, within the MPG data that we've been looking at in prior lessons, right, we may want to create a city rating variable, and that city rating variable is just looking to see, is the city miles per gallon greater than the median city miles per gallon across all of the data? If so, the value is above. If not, then the value is below. And you can see we create a new variable here, city rating, above, and so on. Another example is if we want to look at creating a variable that has multiple values, more than just 2 values based off certain conditions. So in this case, I create a city rating. However, the city rating is going to be one of 3 values, low, medium, high, and it's dependent on, is it within a certain quantile value range. And so we use case when. If city is less than the 0.33 quantile, then it's low. If it is between the 0.33 and 0.77, then it's medium. And if it doesn't meet either one of those, it's going to be high. All right, so what I want you to do, one final your turn for this lesson. I want you to fill in the blanks. So what this is doing is it's taking the NYC flights data, and we are going to go ahead and let's see, we're going to assign each flight to a severity rating of 1, 2, 3, or 4 based on the arrival delay. So we're looking at the arrival delay variable, and what we want to do is, if arrival delay is less than the 25th percentile, then we want to assign it a severity equals 1. If arrival is less than the 50th percentile, or I guess we could say between the 25th and 50th, then the severity is going to be 2. If it's between the 50th and 75th, it's going to be severity of 3. And if it's greater than or equal to 75th percentile, severity is going to be equal to 4. Now, to compute these percentiles, I would use the quantile function. So go ahead and see if you can fill in the blanks and get this code to work. All right, so hopefully you got the answer or close to. You can see here we just use case when, and all we do is fill in these blanks to assess if the arrival delay value is less than the 25th percentile or quantile, right? We're using the quantile to get the 25th percentile. We assign that to 1 if that condition holds. If not, we move on to the next condition and assess if arrival delay is less than the 0.5, and if so, 0.2, and so on, right? So that's how we can easily do multiple conditions within a mutate statement. All right, so we covered a fair amount of things here: an if statement, if-else statement, multiple if-else conditions, which are all not vectorized. Okay, that's kind of the key thing to remember here. And this chart here kind of shows how many conditions do we often look at or check, and kind of where do we often see these functions applied. The next two, right? So the first two are all non-vectorized, which we see here. The next two that we talked about are the vectorized approach of doing if-else, so just a binary conditional check, or if we have more than just 2 conditions we're looking for, we can do case when. All right, so with that, if you got any questions, first I would dig into the lesson reading. It goes into more detail, gives you more code examples to look at and also apply. And if you have additional questions beyond that, then I would turn to the discussion board in Canvas.